To solve the first equation, I'm going to start by adding 4 to both sides. And then I'm going to divide both sides by 3. And I get 36. All right, now that I have the squared part isolated, I can take the square root of both sides. On the left, it's nice. It leaves us with x plus 7, provided that I put plus or minus 6 on the right. All right, so to get x by itself, that's pretty simple. You can subtract 7 from both sides. And this means we have 2 solutions. We have negative 7 plus 6, but also negative 7 minus 6. If you simplify that, we get negative 1. Here we get negative 13, and those are the 2 solutions. X is negative 1, but also negative 13. For the second equation, let's see. Again, I think I'll subtract 7 from both sides. And we get negative 2 on the right. Now this time, if I divide both sides by negative 2, I get x plus 6 squared is equal to positive 1. I'm again applying the square root to both sides, and that leaves me with just x plus 6, provided that I put plus or minus 1 on the right side. After I subtract 6, I get negative 6 plus or minus 1. That means my solutions are negative 6 plus 1, negative 5, but also negative 6 minus 1, which is negative 7. Those are the 2 solutions to this equation. All right, so for the next one, let's see, we get, if I subtract 7 from both sides, 9x squared is equal to 1. And therefore, if I divide both sides by 9, I get a fraction this time, but I get 1/9. It doesn't matter what the number is on the other side of your equation. As long as it's a positive value, you can take the square root of it. On the left, we're left with just x. Now the square root of 1/9 means take the square root of the top, which is 1, and the square root of the denominator, which is 3. And I'll put plus or minus to indicate that those are my 2 solutions. Let's check out number 4. Okay, for this one, I'm going to subtract 8 from both sides. And I'm all set to apply the square root. And on the left, I get x minus 3. And on the right, I get plus or minus, but the best you can write this is the square root of 2. You can type in your calculator, it's going to be a decimal. When this happens, I say we just leave it in this form because it's an exact answer. To get x by itself, I'll add 3 to both sides. So I get 3 plus or minus the square root of 2, and that's really the best you can write it. You can't combine 3 with the square root of 2 in a nice way, so that means we have 2 solutions. 3 plus the square root of 2, but also 3 minus the square root of 2. So either way is fine. You can leave your answer expressed like this, or break it up into 2 separate pieces. All right, so a few other basic equations would be things with fractions. And the approach is going to be take the denominator and multiply it to both sides of the equation. And it's going to instantly take this x minus 3 and put it over here next to the 2. That is, the equation is x plus 1 is equal to 2 times x minus 3. If we're dealing with a fraction, this will be our strategy. Get rid of the denominator by multiplying it to this side. So we've changed it from this fraction to a linear equation, which we know how to solve. I'll distribute the 2. So I get 2x minus 6. I think I'll subtract x from both sides. And then add 6 to both sides. It'd be easy enough to check this back in the original equation. The top is 8, the bottom will be 4. 8 over 4 is definitely equal to 2. The only thing to look out for is the only number you're not allowed to put into this equation is 3, because 3 makes the denominator 0. That didn't happen, so 7 is my solution. Let's try that with number 6. Okay, slightly more complicated, but the idea is the same. take this denominator and multiply it to this side. When we do that, we get x squared plus 5 is equal to, and then you have 3 times x squared minus 9. So it changed from a fraction, not a linear equation, but actually a quadratic equation. So let's see if we can solve that. All right, I think I'll have to distribute the 3. So I get x squared plus 5 is equal to 3x squared minus 27. I'll subtract x squared from both sides, so I get 2x squared minus 27 on the right and 5 on the left. I'll then add 27 to both sides, and I get 32. I'll then divide both sides by 2, which gives me 16. And here I have to apply that square root property where, okay, to solve this equation, I'll take the square root of both sides. The left is going to be plus or minus 4, and the right is just going to be x. Now going back to this original equation, there are two numbers that would be a problem, 3 and negative 3. You can't put that in place of x because it makes the denominator 0. That didn't happen, so these are both solutions to this equation. For 7, again, I'm going to multiply the denominator to both sides. So we get x squared plus x minus 3 is equal to, since this side is 1, and 1 times anything is just that thing, on this side I'm just going to copy down x squared minus x plus 1. And here we go. Any solution to this equation is going to be a solution to this equation. It looks like it's quadratic, but actually, if you subtract x squared from both sides, they completely cancel, and you are left with x minus 3 is equal to negative x plus 1. This thing changed into a linear equation. I think I'll add x to both sides, as well as add 3 to both sides. After dividing both sides by 2, I get that x is equal to 2. The only issue is if 2 makes the denominator 0. So let's see, if I put 2 into just the denominator, I get 4. Minus 2 is 2, plus 1 is 3. Doesn't make the denominator 0. This thing has to be a solution to the original equation. Okay, same idea for 8. Okay, I'm going to multiply both sides by x squared plus 6. And I get 2x squared plus x plus 9 is equal to 2 times x squared plus 6. I'll distribute the 2. That gives me 2x squared plus 12. And again, just like in the previous question, there's a 2x squared on both sides. They completely cancel, and we're left with x plus 9 is equal to 12, a linear equation. And if I subtract 9 from both sides, I get 3. And 3 definitely does not make this denominator 0 because you get 9 plus 6, it's a positive number. Therefore, 3 is a solution to the equation. For the last question, here we have two equations, and I'd like to solve them both. But this is different. You unfortunately can't solve for x squared and then at the same time get rid of this 2x. So unfortunately, our strategy of solving for x squared and taking the square root will not work in this equation. Same thing is true over here. Like, you can't take the square root of both sides because, well, there's still an x on one side of your equation. So in this instance, we just need a different strategy. So let's look at this one here. A good strategy is to see if you can factor this side of the equation. Because it's equal to 0, you can then check to see where each factor is 0 itself. So let's see, can I factor this into two pieces? If so, it's got to be an x and an x, and then we're just left guessing numbers that go here and here that multiply to negative 8, yet add to negative 2. Well, since the last number, negative 8, is negative, it's got to be a positive and a negative. And I think the two numbers that are going to work are going to be positive 2 and negative 4. And this is simply just a guess and check approach. X times x is x squared. 2 times negative 4 is negative 8, but your middle terms are going to be positive 2x minus 4x, which add to negative 2x. So once you have your equation factored, it's very easy to see the solutions. You can just take each individual factor and set it equal to 0. All right, so I'll subtract 2 and add 4, and those are the two solutions to that equation. What about this other one? X squared is equal to x plus 1. Do that one separately here. A good starting point would be to subtract x and 1 from both sides, changing the equation to this. And then you could, again, try to guess the factors. But if you try to guess, it unfortunately won't be as nice as this one. And so we're going to have to use a different strategy. And in that case, I want to use the quadratic formula. The quadratic formula says ax squared plus bx plus c equals 0 precisely when x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So in our equation, a is the number that's in front of the x squared, which is 1. B is the number that's in front of the x, which is negative 1. And c is the number at the very end. You can simply take this information, plug it into this formula, and it'll just give you the answers immediately. So I'm going to try that. The solutions are negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And I'll carefully simplify it. So negative 1 is 1 plus or minus the square root of, okay, that's going to be 1 plus negative times a negative is a positive 4, so that's 1 plus 4 all over 2. If I continue, I get 1 plus or minus the square root of 5 over 2. And unfortunately, the square root of 5 has this weird decimal, so I can't really go any further. In fact, my two solutions are going to be this. 1 plus the square root of 5 over 2, and then 1 minus the square root of 5 over 2. So I'll leave my answers like that. But the takeaway from this problem is, well, sometimes, if there's an x here, you can factor the equation and it works pretty nicely. But other times, it might be too hard to guess the factors, but there's this equation that will solve it for you.